Welcome to Chapter 10. Before we start Chapter 10, we're going to do a quick triangle review from Chapter 5. We're not going to do all of triangles, we're just going to do Pythagorean theorem and special right triangles and a quick review on those. We warned you back in Chapter 5 this stuff wasn't going to go away, so we're going to do a quick review because it's going to show up all through Chapter 10, and if you don't know it, you have very little chance to do the new material. So our Pythagorean theorem, and more specifically Pythagorean triples are three numbers that will always work in Pythagorean theorem. Now you should have some of these memorized. I'm sure you have 3, 4, 5 memorized because that's the easy one. But also there is 5, 12, 13, 7, 24, 25, and 8, 15, 17. Now these three I write in very specific orders because I always put the biggest number last because that is my hypotenuse, and that number has to land on the hypotenuse for it to be a Pythagorean triple. So let's use my Pythagorean triples here. It's just a matter of recognizing them. I know the fact that the side opposite the right angle is always the hypotenuse, so it has to be the biggest number. So here I know 3, 4, 5 is a Pythagorean triple. Blank 24, 25, I know that has to be 7. 8 blank 17, that's got to be 15. And 5 blank 13, that's got to be 12. This is just a matter of memorizing your triples and knowing the fact that the biggest number has to be on the hypotenuse. The other two can be on either side, but the biggest number has to be on the hypotenuse. So now let's talk about reducing. Pretty much everything in Chapter 10 is going to have a Pythagorean triple in them. We're not going to have you actually doing Pythagorean theorem, assuming you can remember your Pythagorean triples. However, they're not always going to be just the 3, 4, 5. They might be a multiple of those, which is how come we call them Pythagorean triple families. So looking here, I have to start by finding a number that goes into both the ones I'm given. So I have 50 and 14. Well, I know that a 2 goes into both of these numbers, which would give me 7 and 25. Well, that means my third number has to be 24, because it's 7, 24, 25. Well, since my original numbers were 2 times bigger than my reduced numbers, this third number here also has to be 2 times bigger. So instead of 24, I'm really looking at 48. I always put my reduced numbers inside the triangle so that way I don't get them confused, because then I know I have to multiply by whatever it is to go back outside the triangle. So now let's take a look over here. I'm going to divide both of these by 5, which would give me 3 and 5. I know the third side is a 3, 4, 5 with 5 on my hypotenuse. Since my original numbers are 5 times bigger than the reduced ones, I know x will also have to be 5 times bigger than 4, so x has to be 20. Taking a look down here on the left, again, I can divide both of these by 2, giving me 15 and 17, which means my third side has to be 8 because it is an 8, 15, 17. And since my original numbers were multiplied by 2, my third number also has to be multiplied by 2, which is going to give me 16. My last problem over here, 25, 65 blank, I can divide both of these numbers by 5, giving me a 5 and a 13, which would make my third side 12 because it is a 5, 12, 13. Since my original numbers are multiplied by 5, my last number is also going to be multiplied by 5, and 12 times 5 is 60. It's all about just dividing and then remultiplying by the same number. It's basically just like ratios that we did in Chapter 6. So now we're going to move on to special right triangles and not Pythagorean triples anymore. Sorry, that shouldn't say that. These are special right triangles. Now I'm going to show you guys 2 ways to do special right triangles. One way is the way we were working on in Chapter 5, and one way is a way based off of ratios. So if you never really got it in Chapter 5, maybe this second way I'm going to show you today will work. Okay? So the first way, the way we talked about in Chapter 5, was recognizing that I've got 3 sides of a triangle here. I have the 60-degree angle and the 30-degree angle and the 90. And my sides are all based off those angles. Opposite the right angle is the hypotenuse. Opposite the 30, because 30 is less than 60, this would be my short leg. And opposite the 60, because 60 is bigger than 30, that would be my long leg. So the first way we had you guys kind of think about this stuff was all based off of arrows and just remembering ratios. Now this triangle that you have here with the x, the 2x, and the x rad 3, that's on your Ames reference sheet, which you will be allowed to use for this test. So you will be able to see these ratios. So all you have to know is how to use them. So to go from the short leg to the long leg, we're going to multiply by radical 3. So that's times radical 3. And to go from the long leg to the short leg, we're going to divide by radical 3. So whatever number's on the long leg, divide by radical 3, and that'll be my short leg. If I have the short leg, you multiply by radical 3, and that will be your long leg. And that's where this radical 3 shows up at. Now, if I have the hypotenuse, to go from the short leg to the hypotenuse, we multiply by 2 times 2. Because instead of x, we have 2x. And to go from the hypotenuse to the short leg, we're going to divide by 2. So that's how we kind of showed you guys how to do it back in chapter 5. The other way I can look at it is write them as ratios based straight off of chapter 7. I can sit here and I can say the long leg to short leg ratio equals x rad 3 over x. So the side of my long leg over the side of my short length equals x rad 3 over x. Because you're still always going to have to go to short leg. I never connect long leg and hypotenuse. You never connect those. And if I wanted to go from the short leg to the hypotenuse, my ratio would be x over 2x. And I'll show you here on the next slide how I'm looking at using these ratios. But if you want to use them based off ratios and then just cross multiply and solve, that'll absolutely work. So let's look here. My 10 is my short leg because it's opposite the 30. And don't forget that these triangles are going to be turned around. My ones for this example will all look the same, but they are going to get turned around. So let's go to my long leg. You can either remember that from short leg to long leg means you multiply by radical 3, which means this one here would be 10 radical 3, because 10 times radical 3 is 10 radical 3. Or you can go like this. The short leg over the long leg equals x over x radical 3. Well, I know my short leg is 10. I do not know my long leg. X over x radical 3. Now, x over x can cross out and simplify because anything divided by itself is 1. Now, if I cross multiply, 1 long leg equals 10 radical 3. Same answer, just a different way to do it. Either one is absolutely going to work. It's just a matter of what you feel comfortable with. Now, to go the other way from my short leg to my hypotenuse, I'm going to multiply by 2. You can just memorize that, where this here is going to be 20. Or again, we can use a ratio. Short leg over hypotenuse equals x over 2x. My short leg is 10. I don't know my hypotenuse. X over 2x. Again, I can cross out the x's because they're on top of each other, leaving me a 1. So 1h equals 20, which is the same thing I found out. Now, when we do the slides later on in chapter 10, I'm not going to be showing the ratios. I'm going to just be doing, hey, you multiply by this or you divide by that. But if you need to do the ratios, do the ratios. It's a matter of coming up with the right answer. Let's try another one here. Here I started out with my hypotenuse, and I want to go down to my short leg because that's opposite the 30. So I'm going to divide by 2, which is going to make this 6. Or I can say short leg over hypotenuse equals x over 2x. Again, where am I getting this from? That very first slide I showed you with x, 2x, and x radical 3. That is on your Ames reference sheet. I can cross out the x's. I can replace the short leg with 6. So 6 over the hypotenuse. Nope. I don't know my short leg yet. Sorry, let me start that over. I don't know my short leg. That's what I'm looking for. But I know my hypotenuse is 12 equals 1 over 2. So 2 short leg equals 12. Divide by 2. So my short leg equals 6. That's how I can come up with my short leg. Then to go from short leg to long leg, I multiply by radical 3. Or you can set up another ratio. Let's take a look here. I've got the long leg to start with. And I know it's the long leg because it's opposite the 60. I want to go to the short leg first because, again, you never go from the long leg to the hypotenuse. So to go this way, I have to divide by radical 3. So I'm going to do that math up here. I've got 18 divided by radical 3. You can never have a radical on the bottom, so you have to multiply the top and the bottom by radical 3, which would give me 18 radical 3 over 3. Now, how did I get that 3 on the bottom? Well, radical 3 times radical 3 is radical 9, and radical 9 is really 3. Then I can simplify this and call it 6 radical 3. So my short leg here is 6 radical 3. To go from short leg to long leg, you multiply by 2, which will give me 12 radical 3, because 6 times 2 is 12, and you don't multiply the radical. Let's pretend instead of doing that, I wanted to do the ratios. Long leg over short leg equals x rad 3 over x. I know the long leg is 18. I don't know the short leg. I can cross out my x's, leaving me radical 3 over 1. So radical 3 short leg equals 18. Divide by radical 3. And that puts me back up here at all of this math. And then I can do the same kind of ratio for the hypotenuse. Short leg over hypotenuse equals x over 2x. The short leg is 6 radical 3 over the hypotenuse, which I don't know. I can cross out my x's, 1 over 2. Cross multiply, 12 rad 3 equals my hypotenuse. Again, guys, whatever you feel comfortable with. If you can just remember what to do, great. If you want to write up a ratio, awesome. Now we're going to talk about my other type of special right triangle, which is a 45-45. The first thing you'll notice is that both of my legs are the same, so both legs are equal. And this is still my hypotenuse because it's opposite the right angle. So I can again write ratios. This is again on the Ames reference sheet. Leg over leg equals x over x. And I can simplify. This would be 1. So the legs are always the same. Leg over hypotenuse equals x over x rad 2. Cross out the x's. 1 over radical 2 can still simplify. So let's use these ratios here, or we can remember the fact that to go from leg to hypotenuse, we are going to multiply by radical 2. And to go from the hypotenuse to the leg, we are going to divide by radical 2. And the legs are always equal to each other. So we'll go here now. I have a leg because it's obviously not the hypotenuse, because hypotenuse is opposite the right angle. And I know both of my legs are the same. That is the easy one. To go from the leg to the hypotenuse, I multiply by radical 2. So this is 15 radical 2. Or I can write up a ratio, leg over hypotenuse equals x over x rad 2. I know the leg. I don't know the hypotenuse. X's simplify, 1 over radical 2. So 1 hypotenuse equals 15 radical 2. Any way you go, guys, it doesn't matter. Just make it happen. And our last example, I've got 8 radical 2. That is my hypotenuse. So to go from the hypotenuse to the leg, I'm going to divide by radical 2. 8 radical 2 divided by radical 2. Just like anything else, when they're on top of each other, they cancel. So my leg is going to be 8, which means my other leg has to be 8. Or I can write up a ratio, leg over hypotenuse equals x over x rad 2. I didn't know my leg. I knew my hypotenuse was 8 radical 2. Cross out the x's, 1 over radical 2. So L radical 2 equaled 8 radical 2. Divide both sides by radical 2. L equals 8. Again, guys, either memorize what they are and multiply. You're going to have an Ames reference sheet, or set up some of these ratios. Have a good day, guys. We'll see you tomorrow in class.